All right, so we're going to be covering a paired t-test this time through. Paired t-test is when we have within subject design, meaning that we have a single group and two scores for that individual group, such as comparing McDonald's to Burger King, where both people taste McDonald's and Burger King, or they get a pre and a post test. This is known as a dependent samples test, specifically dependent samples t-test, because each sample or each group is dependent on the other one. Degrees of freedom is n-1. We're going to talk about confidence intervals, how to calculate them. We have effect sizes, we have cones D, and R squared. R squared is calculated the same as we had in the independent t-test. And then we will talk about the non-parametric alternative. So matched group design. If you recall from the paired, we talked about paired t-test before, and we talked about experimental design. Matched group is done exactly the same way. And we can use a matched group design for a paired t-test. We identify participants matched on some meaningful characteristic and then randomly assign one member of each pair to one condition. It creates greater internal validity, but it is really a challenge to do. Paired t-test is used with matched groups and repeated designs, pre-test, post-test. It involves converting raw scores to different scores called D. Different scores are then analyzed with the same formula as a one-sample t-test. All right, so if we look here, you can see we now have pre, post, and difference. So on a score from 1 to 10, we can rate how much people have statistical knowledge. So before the test they had 5, 2, 7, 6, and then after the class 8, 5, 8, 6. And so as we just talked about in the pair t-test, we have to calculate a different score. So this would be -3, -3, -1, and 0. From here, we need to calculate the average, which through Excel we can do very easily. So we end up with an average of -1.75. We can calculate a standard deviation for the sample. Which is 1.5. And then what we normally assume the difference is going to be is 0. So it's going to look something like this: -1.75 minus 0 divided by 1.5. So really what it's going to become is -1.75 divided by 1.5, and we end up with a t value of -1.1667. We got the average the same way. We calculate standard deviation the same way. I did not go over it because we've covered it previously. Standard deviation is still each of these individual scores minus the mean squared. We add those all up and then divide it by little n minus 1 because it's sample. In this case, it's 1, 2, 3, 4. We've seen the one sample t. Now we would go through and calculate the critical value. We look up the critical value and we use our same rules as before, where we draw it out. We look up the critical value the same way. We're going to have a new way of looking up degrees of freedom. Degrees of freedom will be n-1, which I will go through in a little bit more detail later. A quick review: independent t-test assumptions. Dependent variable is measured on an interval or ratio scale. Two independent groups. Observations within a group are independent of each other. Both samples are drawn from a normally distributed population. And we have homogeneity of variance, which means that the variance for both groups is going to be equal. So if we have males versus females, they will have the same variability, even though they might have a different mean, such as for height. Paired t-test, the dependent variable is also on an interval or ratio scale. Samples, dependent again. Not again, samples are dependent. Meaning that if you're in one group, you're in the other group. We talked about this before and how that helps us keep internal validity high and reduce individual differences. Each of the two scores is drawn from a normally distributed population. Homogeneity of variance, again. We set this up as a one-tailed or two-tailed. These are the three options. The alternative works just like any other t-test that we've used beforehand. So if you look over in the two-tailed, it says equal. Guess what? The alternative is not equal. These are all essentially saying the same thing for two-tailed. mu1 equals mu2 is the same thing as any value minus another value equals 0. That means they're the same. Another way of talking about difference is something minus itself. That's a difference, which is why we have mean difference. That's why we have those three options. I recommend that you stick to the top one, but whatever works best for you, go for it. The one-tailed, again, notice how we have for the null, less than or equal to, so the alternative would be greater than. Same rules as we had previously. All right, so we can do another example where we have drug is the independent variable, the dependent variable is the number of headaches. In a two-tailed, you can see how this plays out, where we have the mean drug equals the mean placebo, and the alternative is not. Now notice degrees of freedom is going to be n minus 1. Before, for an independent t-test, it's n minus 2, large N, or n1 minus 1 plus n2 minus 1. Here we do not have that. And same rejection rule. Confidence interval is the same way that we've been doing previously for the difference between the means. Mean difference is the difference between the means. It's the same thing. So in our example, where we have negative 1.75, it would be negative 1.75 times our standard error of the mean. Sorry, plus or minus our standard error of the mean times our critical value. As before, you need to make sure that you use the two-tailed t-crit. Cones D, pretty simple. It's the mean difference over the standard deviation of the difference. So Cones D, pretty simple. Mean difference over the standard deviation of the difference. R squared, same as for the independent t, which is t squared obtain divided by t squared obtain plus the degrees of freedom. So in our case, it would be negative 1.166 squared over negative 1.166 squared plus 3, because that's our degrees of freedom. Non-parametric alternatives, Wilcoxon matched pairs. We use when assumptions have been violated and converts interval or ratio to ordinal. We'll go over in class how to do the pair t-test. Remember, we reject if p is low. Here is how to write out a t-test in APA style. Homework 7B will be due right after in 1 week from whenever it is assigned in class.